When I was just a little boy, we'd often take family trips to the nearby industrial heartland. Out of the window of the family car, I could see the giant head frames and smokestacks passing by. But the wheels weren't turning anymore, and where there once would have been fires burning that never went out, the blast furnaces were sitting peaceful and silent, as in a slumber. These giant structures left a lingering impression in this boy's mind of the power of man, but also of the end of an era and of the pride of my own people slipping away. Some of these mines and steel mills had been turned into museums, and the few remaining workers who gave tours of these places told us of the days when thousands of men would crowd the streets early in the morning to march to the iron and steel works. Even in the 1960s, few people in Germany could afford a car, so they walked. Can you imagine the feeling of walking to your job through the streets of your town, while with every corner you cross, more people join the march to go to the same place, to work on the same concerted effort? I certainly can't know how it feels, because I've never done it. As we face a more atomized time, where more and more people don't see the meaning in their own work anymore, many understand that we didn't just lose the capabilities we had, we also lost a sense of purpose. Of course, lots of people will tell you all kinds of reasons why it had to happen. But at the end of the day, despite all political and economical complexities, there is one self-evident fact. As I pick old tools and equipment from the scrap today that were made in those days, the dedication that went into their production is obvious. It really seems like people found purpose in doing their job as good as they could to make a product that everyone could be proud of. So let's see what I found and what I have for you today. So I found not one, but actually two heavy winches made from cast iron and forged parts. It'll be a lot of work until I can really reuse them here in the shop, but it'll be worth it. This heavy pulley is another find that we will be able to use alongside those winches. And since I want to power them with electric motors, I also bought some gear motors from the scrap as well. Once again, I have also found the time to restore a new swing of old German military toolboxes that are now for sale again. More about that at the end of the video. Over the years, I have also collected this pile of old German hand tools. I won't have the time to completely restore them in this episode, but we will at least start to work on them today. So there's a lot to do, so let's not waste any time. So a while ago I found this massive pulley here on the scrap. What I did back then was to take it apart by cutting through one of the original welds that held its outer frame together. I did this in order to remove old grease and also the old red paint job. Back then I used paint stripper to get this done. However, for a while this project was put on hold. But now is the time where I could actually use this pulley, and that's why we'll now finish that job. And well, this job begins by removing the rather light layer of rust that has formed on its surface since we first removed the old paint. This is done by wire wheeling. On top of that, I also grind down the remnants of the old weld to prepare the piece for being welded together once again. In order to make sure that the pulley will actually be able to move freely, it's important to weld the parts together as they were before. That's why I first only tag them together and check if the pulley can actually run freely. After having done that, I eventually use my TIG welder to make the frame whole again. And this is what it looks like now. Since the frame is actually open in the top, you know, where the big hook is, the other point where the frame needs to be welded is here, where this steel rod acts as an axle for the pulley. So that's what I did next then. And after the steel had cooled down, I start to paint the frame and the pulley, and I decided for a new color scheme with silver colored hammerite for the frame and yellow paint for the actual pulley. And a few days later, after the paint had dried, I installed the pulley up here, hanging down from the gantry. And this is where we will test it later in this video. First, a few other things still had to happen though. So let's have a look at this stash of antique hand tools then. This is not one big score though that I simply stumbled over. It's a collection of odds and ends that I found over the years. I put them together in a container under my workbench until I figured that it was time to take care of the whole lot. And what I'm trying to do here first is to sort these objects into related groups. Some of them came in these old-fashioned steel bins here, and I reused them to bring order to the chaos. And one thing we have a lot of are old pincers and cutters. In theory, they could be reworked into blacksmith tongues. We also find a number of old German-made files. The handles are missing with some of them, but otherwise they seem to be in good condition. And another loosely defined group of tools are various large pliers and tongs. And similar to that, an assortment of historic adjustable wrenches of various forms. And then we find something that always reminds me of my childhood and playing in my dad's wood workshop, a bunch of wood chisels. Also, rather randomly, a number of pulleys and block and tackle mechanisms. Another item I have found over and over again are old axes, and we have quite the collection here. And after removing more odds and ends from the big pile, we are mostly left with a collection of rusty wrenches of all sizes and shapes. So after sorting them into these rough categories, I proceeded by stringing them up on pieces of wire. You could use twine or rope, I just have a lot of insulated wire, so that's what I'm using. I did that to suspend the parts in this barrel filled with citric acid, and I'll have to leave it in there for a while. Other small items are just put in plastic containers where that same reaction with citric acid is taking place. Now we'll have to wait here for a while until the rust is gone, and then later in the video we'll check back in and take care of these tools. So let's have a look at those two winches then that we found on the scrap. Both of them will have to be repaired, but they will also be upgraded to run on electric power. And we will do that using some of the gear motors we have also found on the scrap over the years. This will be quite the project, so let's not waste any time and begin with the somewhat smaller winch painted green. This particular type of cast iron pulley tells me that this winch was used in conjunction with a chain, like in a chain hoist. One of the spokes is broken though. The shaft of the worm gear is also severely bent. We won't need that broken pulley anymore, and that's why the first order of the day is to remove it. And with that pulley out of the way, we can have a closer look at the winch itself. Apparently it was made by a company called Gedi in 1961. And as you can see here, the bottom steel sheet is severely dented, and we will have to take care of that as well. This worm gear that engages with the drum of the winch was made from die-forged steel. It connects to a ratchet wheel via a friction disc. I will demonstrate and explain the purpose of this in just a minute. But first we need to take care of the most important issue, the bent steel shaft. And in order to make that possible and take care of a number of other issues, we will now completely disassemble the winch. And after applying some penetrating oil and letting it sit for a while, I managed to unscrew the old nuts so we can lift off this top part of the frame of the winch. Unfortunately, this cast iron bushing is somewhat damaged and the steel part around it is bent as well. But we can now also disassemble the most complicated part of this winch. We find a washer, followed by a ratchet wheel, and finally the friction disc that I mentioned before. It's super dirty on its bottom side, but here on the top you can see what it's actually supposed to look like. And here the bent steel shaft. That shaft sits on a single steel ball, by the way, that normally would also be lubricated. On the bottom side of its counterpart we find a dimple that fits the surface of that steel ball. In the next step, I'm removing the massive steel shaft that the drum is sitting on. It's secured by a single bolt that connects to a piece of steel that was welded to that shaft. And after a little back and forth, I was able to pull it out and free the cast iron drum from the welded frame of the winch. All that remains now is a spring and the pole of the ratchet mechanism. The German word is Sperrklinge. It is secured with a retaining ring. And after also retrieving that steel ball, the winch is now completely disassembled. Now, the keen observer might have noticed that everything is really dirty and rusty here, and I started to take care of that right away by degreasing all the parts using solvents and degreasers of various kinds. But while that degreaser is working its magic, let's try to take care of the mechanical damage. The top end of this steel part, where it protruded from that bushing, is clearly bent. Unfortunately, this is typical damage that occurred while this part was dumped on the scrap. Since the shaft is 24 millimeters in diameter, there is no way around heating it up to bend it back in shape. And after clamping it into the 3-jaw chuck of the lathe on one end, I begin by preheating the bent section using a propane torch. But we know from experience that a puny little torch like that isn't powerful enough to do that job. That's why after a long time of inactivity, the oxy-fuel torch is called back to action. And after heating it up somewhat more, I attempted to bend the shaft by hand. But I was too hasty here and had to attempt it a second time, and this time I heated it up even more. In fact, you can already see the steel burning away on the surface. Now I used a small mallet to force the end of the shaft back into alignment. And after that I also did a tiny bit of machining on the shaft to really make it run true again. More repairs will need to be done here, and I'll show those in just a minute. Those repairs are more cosmetic in nature though, and the most important step now is another one. With the shaft straightened, the winch is operational again, but we need to decide how one of our scrapyard motors can be attached to this shaft. One motor that could go well with this winch is this one here. So let's have a closer look at it for a moment. It's a brushed DC gear motor with a warm gear. Nominal supply voltage 40 volts. It was sold under the German Kone brand, and I think this is the type of motor used for elevator doors. It was made in 2015, and I find these motors on the scrap quite regularly. It's the kind of component that simply has to work for obvious reasons. Under the black plastic cover on the backside of the motor, we find a photo interrupter that can be used to operate the motor as a simple servo motor in a closed loop system. By the way, I have noticed from comments under some of my older videos that some of the viewers out there seem to believe that all worm gears are self-locking or non-backdriving. But that simply isn't true. It depends on several factors, such as the lead angle and friction. This one is not self-locking. And think about it for a moment. Do you want self-locking elevator doors? But be that as it may, the motor shaft is fitted with a tooth belt pulley. And I would like to use a tooth belt to connect it to the winch anyway. However, ordering a second pulley that fits this one is prohibitively expensive. Like in my video where I built that CNC milling machine, we will instead use cheap automotive parts instead. This is a third-party crankshaft pulley for old VW cars. They are old-fashioned, non-magic pulleys, but they only cost a few bucks and are easily machinable. In this case, we'll have to make an adapter part to fit the pulley to the motor shaft though. And while the inner diameter of this pulley is too large for the motor shaft, it is too narrow for the shaft on our winch. Now we could bore it to 24 millimeters, but instead of doing that, we could also use a VW camshaft pulley instead of a crankshaft pulley, which by mere chance happens to fit on this shaft just fine. The difference in size will also result in a further reduction in rotational speed and an increase in torque, which is what we need in this application. Now this might be a very specific application, but believe me, what I show you here is a life skill. I spent many years of my life finding affordable ways to make things fit together that were never meant to. Many people have plans and they found a motor somewhere but never managed to actually connect it to anything. In order to make the crankshaft pulley fit, I'm now reusing an old leftover piece of aluminum round stock. It's not running true, but that doesn't really matter since we will machine it inside and out. A center drill and a number of ordinary drill bits are used to drill a 10mm hole into the round stock. And after making sure that the inner diameter really fits the motor shaft, I then started to reduce the outer diameter of our adapter piece step by step as well. When doing this, you need to be really careful not to cut off too much material, or you can start all over again. After press fitting this adapter into one of the crankshaft pulleys, I then decided to do a little bit of milling on the motor shaft. I won't reuse the keyway on the shaft and have decided to just mill it flat on one side instead. And after doing that, the cool old drill press we worked on in the last video is now called to action. In case you haven't seen that last video yet, you should definitely check it out. I linked it under this video. And after drilling through the pulley's hub and the adapter inside, I proceeded by tapping the hole so that a set screw could be inserted here. The pulley can now be fastened to the gear motor. However, in order to go forward with this, we will have to weld parts to the winch's frame, and that's why it's a good point in time to get rid of the old paint job. Since the paint was rather thick and resistant, I used flap discs for that, and I did my best to remove it from all accessible surfaces. The remaining paint will be taken care of in just a minute. The next step was to take care of the bend in the top part and the big dent in the bottom sheet. In order to straighten it properly, the cast iron bushing needed to be removed temporarily. I did that by machining down the old rivet heads until I could drive out the rivets using a punch. And after doing that, a few precise hammer blows were all it took to straighten it. In order to straighten out the bottom, the oxy-fuel torch was needed once again. And after heating up the deformed area, again only a few calculated hammer blows were necessary to straighten out the situation. The top part of the winch's frame was now also modified to accommodate the motor. For that purpose, this section was cut off, and a piece of flat stock was also cut and deburred before being welded to the frame. And this is what it looks like right now. In the next step, a screw clamp was used to attach another piece of flat stock temporarily until it was decided where exactly we needed to drill which holes to install the motor. Then, after pre-drilling, a 14mm hole was drilled into the stock and the milling machine was used to extend that hole into a slot. Could it all have been done on the milling machine in the first place? Yes, but then again, lots of things can be done on the milling machine in the first place. After making sure that everything actually fits, a few more holes were drilled where the motor would be bolted down. And since the keyway on the camshaft pulley is way narrower than the old key, it was then also machined on one side to both fit the wide and narrow keyway and connect both parts properly. In the meantime, I had also designed and printed some parts on the 3D printer. When bolted together, they form the flanges of the pulley, making sure that the belt won't fall off during operation. Currently, the flanges are only loosely attached, and they are also not super tight fit and are not properly centered. I'm still testing the general idea of 3D printed flanges, and I will make an improved version after a while. And like with the smaller pulley, we also tapped the hub to fasten the pulley to the shaft properly. It was now time to put everything together and let it all spin freely. To adjust the parts a little bit here and there until the alignment was all correct. There is no point in welding misaligned parts in place. This took me a while, but in the end it all worked out fine. In the meantime, I had also been able to score this roller fair lead here on an online marketplace, and I had decided to bolt it to the winch as an option. Depending on the eventual use case, this might come in handy. And in order to make it fit the winch, it was necessary to cut, drill and weld a few more pieces of stock, of course. Last but not least, a rope would probably come in handy here. Now, I found these 40+ meter long cables here on a scrapyard a while ago and was able to contact the manufacturer and identify the ropes. However, they might be a little too long, and I don't want to cut these great ropes here before I haven't decided on their eventual future job. That's why I decided to drive to the hardware store and buy the strongest rope they had instead and install it in the winch. In theory, we could now test the winch. But there are, unfortunately, still a lot of other things we need to prepare for that. And we also have a second winch that I also decided to repair and modify here. So let's take care of our second winch then. Since many of the necessary steps were the same, I will skip over those parts that we have basically seen already and focus on the differences. First of all, this red winch is heavier and has a wider drum diameter than the green one. The drum is somewhat narrower though. In its original application, it was operated by a hand crank. Despite minor differences, the general construction style is so similar that I'm willing to believe that these two devices were made by the same company. One of the first things I did was to remove the hand crank. I did that in order to free up the shaft it was sitting on. In this case, I also had decided to use a chemical paint stripper early on to get rid of the old paint job. It worked reasonably well, but as I mentioned in the past, using paint strippers is nasty business and I don't like doing it. Unfortunately, that die-forged worm gear part suffered from the same problem as with the first winch, a bent shaft. And like before, we used the lathe and the oxy-fuel torch to straighten it out. But since it was also slightly tapered and had lots of damage on the surface, I decided to shorten it somewhat. The top of the cast iron bushing was also milled down by a few millimeters to make some room. With a straightened and shortened shaft, we are again at that point where we have to decide which motor to fit to the winch. This time I decided to salvage the motor from this scrapyard find here. I first wasn't sure what this was from, but it turns out it was a stair lift manufactured by the famous German company ThyssenKrupp. When I hear that name, I think of steel mills and super heavy manufacturing. But apparently at one point they also made this stair lift. But be that as it may, while disassembling this part, I was able to salvage this really heavy DC gear motor that was apparently manufactured in Italy. This doesn't happen every day, unless I repair coffee machines, for example. So I guess I'm sending my best regards out to the viewers in Italy. Leave a comment below, guys. So there are a few special things about this motor. For one, there is a brake connected to the motor shaft. It has to be energized in order for the motor to spin, And this is actually a really nice feature for the winch. Instead of a tooth pulley, there is a spur gear pressed onto the gearbox shaft though. And while it can be hard at times to identify tooth belts and tooth belt pulleys because there are so many different profiles and sizes out there, it's usually a lot easier with gears, at least here in Europe. So what you need is basically just two measurements. You need the pitch circle diameter, which you can guesstimate or eyeball by simply measuring the diameter at roughly half of the height of the gear's teeth. Then divide that by the number of teeth, and that gives you the module. Using that method, I was able to find out rather quickly that this is a Module 3 spur gear. So what I did next is to buy another Module 3 gear that I found online. We will use it to connect motor and winch. In this case, we are in the opposite situation though we faced before. The inner diameter is too small. When trying to increase holes of this size to a larger diameter, you can use a boring bar instead of a drill bit, and that is exactly what I did here. I increased the size of the bore incrementally until I could just barely fit it around that shaft. And here are two details that I wanted to show you. Now, I mentioned before that these parts appear to be forged and machined rather than just machined. My reasoning is that you see these raised ridges alongside the piece. I'm sure they are flash lines that were created while two forging dies were pressed together. The surface of the worm gear was then probably also machined to some degree. The part is certainly not made of cast iron. Otherwise, it wouldn't have been possible to be deformed like that without breaking it. Nor would it have been possible to bend it back under heat. Cast also has a completely different grain. In my opinion, die forging the gear and then machining the surface afterwards speaks for the high quality of these winches. A second detail that I wanted to talk about here is the fact that the former owners simply welded the shaft to the ratchet wheel. Probably because they maybe didn't understand why there was a friction disc between them. The friction disc also probably didn't work well anymore because it's too dirty and greasy. I removed the weld and I will demonstrate the friction disc in action in just a minute. In the meantime, I had also used an angle grinder to wire wheel the surfaces of this winch. We need bare metal, as we will do some welding here as well. The winches will also both be painted, but I will only do that once all the modifications are completed and tested. There's little point in painting parts that you will likely cut, drill or weld in the near future. And like with the motor shaft of the other winch, I'm now using the milling machine to create a flat surface on one side of this shaft here as well. This is where the bored out gear will be installed, and in order to make that happen, a hole has been drilled and an M8 thread has been tapped into its hub. The milling machine can be used to cut threads as well. In fact, I bought a thread cutting head for this purpose alongside the machine, but I've been hand tapping things for so many years now that I simply feel more confident doing it this way. The motor will now be installed roughly like this. Only this time it was actually much more complicated to make the part that the motor is bolted to. For that purpose I had taken a piece of 8mm steel plate from a scrapyard and I cut it into a rectangular shape. Sometime before I had tried to find a way to find out the bolt pattern needed to install the motor. This was quite difficult. I first made a rough CAD drawing of the motor. It doesn't have all the features, but it has all the parameters that are important here. I then designed these two parts that could be used to properly install the motor somewhere. Out of these two, this part is the more important one. So I printed it out on a 3D printer and saw if it actually fit the motor. I actually then had to modify the CAD drawing and print a second template until it actually fit. Now I used this template to scribe a hole pattern on this piece of steel, but that was for the smaller mounting holes only. The big hole in the center was cut out with a CNC plasma cutter instead. I know this sounds overly complicated, but here's my answer to why it's still worth it to do things like this. People ask me all the time, how do you know this and where did you acquire this and that skill? In 95% of cases the answer is I always do everything the hard way and try to train myself in as many things as possible. I could have made a template from a piece of cardboard and that's that. But this way I exercised making precise measurements, 3D modeling, 3D printing, generating tool paths for the plasma cutter, etc., etc. It all takes much longer, but the only way to get good at anything is to practice. In the future, much more complex problems will come up in my work, and I will only be ready to tackle them if I practice while I can and while the stakes are low. And just like with the first winch, we only connect everything loosely and with some wiggle room until we have made sure that all parts run smoothly and are aligned correctly. When working on something with moving parts like this, never weld everything in place too permanently before you have tested it, or you will ruin your own work. It also needs to be mentioned that gears are less forgiving than belt drives when it comes to misalignment. And there are a few more things here as well. In case the old friction discs can't do the job anymore, I have tried to source new ones. These have roughly the right size, but we'll have to see if they are really suited as replacements. And like with the smaller winch, I decided to bolt a roller guide to this one as well. Once again, it was quite a lot of cutting, drilling and welding until I was at the point where the guide could be installed, but I'll spare you the details here. After installing a really flimsy piece of rope to the drum, just to see if it works in principle, I went home and thought about ways to test and demonstrate the winches here in the shop. Long term, I want to use the winches together with a small loading crane and with my trailer. But those things need to be built first. But I'm making this video now. So I had to come up with ideas of which structure or fixed point to attach them to. And here is what I came up with. So my actual plans for these two winches have nothing to do with this demonstration here. At least one of them will be installed on my trailer. But there simply isn't enough time to do the trailer conversion as well before this episode needs to go online. So I figured we could actually test the heavy pulley and both winches by connecting them to the gantry that I built earlier this year when I hauled the milling machine here. So here is what I did. A scrap steel plate was cut once again with the CNC plasma cutter to be large enough so that both winches could be installed here if needed. It was then placed onto the lower part of the gantry where the bolt patterns of both winches were drawn onto it. The plate was then tacked to the gantry so that it would sit firmly in place for the next step. The magnetic drill that I built a few weeks ago was then used extensively to drill all the holes for the winches to be bolted down. Some of them were 14mm holes that needed to be pre-drilled, others were 20mm holes that we used the annular drill bit for. And with the first winch bolted down, we can now perform a few tests. So what I'm doing here is to reverse the polarity on the motor and lower the load again. The reason why it's so slow at this specific point in time is because I have turned down the voltage down from 40 to 10 volts. What you can also hear is that the ratchet doesn't engage when you reverse the direction. And you can see it here in the test where I only lifted the 65 kilogram faceplate. The ratchet engages while hoisting it up, but it stays idle as I lower it down. And that is the purpose of that friction disc between shaft and ratchet wheel. You couldn't have a ratchet and also be able to lower a load that is attached to the rope. And here I'm simply repeating the same thing with the formerly red winch, the one that's a little bigger. And well, let's lift some stuff here as well. So according to nameplates that I found on pictures of other old winches of the same size, I know that these could actually handle way more than what I'm doing here. And you will see some applications that will really put them to the test in the future. However, for now, this is all that I have for you in terms of demonstration material. So, as I said in the very beginning of the video, I have started to work on this huge pile of hand tools. But since this video is already 35 minutes long and I've been working for a couple of weeks on this episode, I just didn't find the time to completely finish this job. So a lot of the tools are still in the asset, others are being worked on right now. And I want to upload another video. I'm planning to upload it 7 days from now, next Saturday. And in that video, we'll go into the restoration of these tools and also dive into the history of the manufacturers of these tools and maybe learn a little more about the steelworks that I visited today. I think that will be a very interesting video. And if you want to support the production of videos like that, I'd ask you to become a supporter on Patreon under patreon.com/tpai. The other thing that I wanted to talk about are my toolboxes, and they are for sale again, so let me explain how that works. So guys, if you want to buy one of these toolboxes, then the way to do it is to send me an email at tpaimerch@gmail.com, and I sell them all in bundles. That means that you will get a toolbox, and included with the toolbox are 5 or so of my self-made stickers. And then there will also be a handwritten note on one of these historic postcards here. Many of them are from East Germany, actually. And then I will also include 1 or 2 wrenches, depending on how much weight there is left, right? So we can't go higher than 10 kilograms for these packages. And I might also include other historic items with some of the boxes as a little extra. So if you want to buy such a bundle, just send me an email at tpaimerch@gmail.com and let me know where you live so that I can send you an offer with the correct shipping cost. And PayPal and other means of payment are possible. Just ask for it and I'm sure we can get it done. So waiting for your emails. Shipping to all countries is possible, by the way. So I'd love to hear from you and see you next week then.